Hello. Assalamu alaikum.
जी,
Should I start?
yes, bhai. You can start.
Okay. Okay. Thank you. Welcome everyone. I'm Shuman, welcoming you to our hands-on workshop today. Initially, I'll give an introduction about myself, and thanks,
Okay.
Mim, for organizing this workshop today. I'm sorry that
Can you screen share this one? Screen to share
I
the
have not
video.
shared my screen yet. Okay, I'll
Okay.
share. Let me share. Mm, give a second. Yeah, I have shared my screen, but it's not in the visible area of the live, I think. Can you see if you can add it to the?
Yeah,
Uh, I'm not sure if I have the option or not. Oh, yeah,
yeah.
it's
And now
fine
you,
now.
you can see.
Thank you. Yeah. At first, I want to thank you, Joy, for organizing this workshop today. Though, I had committed that I would take this workshop like couple of times back, but I was visiting Bangladesh, and so I had to reschedule it couple of times. But I'm happy today to conduct this workshop. So is it going live in like couple of channels, right? Facebook, YouTube, and LinkedIn.
Yeah, it's LinkedIn and YouTube channel.
Mhm. Okay, yeah, fine. Yeah, then let's start. And it's an workshop organized under AWS Community Builders Bangladesh user group. So I'm a community builder. I know Joy is also a community builder. So maybe at the end of the session, we may discuss couple of more information about what is community builders and how one can join this initiative. But let's start the session. So today, at first, I'm going to talk about containerization. So, what is containerization? If we take a look at the definition, it says that a lightweight form of virtualization that packages an application and its dependencies together in a single unit called a container. So we develop applications and different languages. We use different libraries, dependencies, and to run these applications we need a specific environment. For example, if we want to run a Java application, we will need to install JVM, and depending on our application we will need different config files, libraries. For example, if we want to run a Spring Boot application, it will need Spring related dependencies. So you can see that if we want to run an application while in development or in production, there are actually lots of dependencies. So containerization, it actually helps us to make sure that all the necessary things are ready when we need to like deploy an application or wants to run a application in our local system. Previously, we would install all the dependencies in our local machine. The developer would develop the application, run it there, and then if we wanted to share the application with other developers, they would also need the same environments, like the dependencies needs to be installed, the JVM or whatever server we need, all needs to be installed. So containerization helps us to take away these extra steps from us and make sure that we have the development environment ready and it runs consistently across different environments. So containerization gives us a very solid foundation to develop and run our application. And what benefits do we get by using containerization? So it gives us portability. So when we develop a application, it can be, and containerize it, it can be easily shared with our fellow developers, it can be easily deployed in different environments in different servers, so it becomes portable and very easy to manage and share. It gives us efficiency because now we have to spend less time preparing our environments, and we only containerize the dependencies, only the things that we need to run the application. So it makes us efficient, and it becomes much easier to scale because we can create this environment once, or containerize our application once, and then we can easily deploy it in multiple environments as many times as I want. And it gives us security and isolation, as the container is isolated and it's only has the thing that we need to run the application. It becomes much easier to manage the security. It's isolated, it does not contain or cannot communicate with other outside world, and outside world cannot also communicate with container. We can only enable the or configure the response we need from outside world, and we can only open the port that we need to allow outside world to connect to. So it becomes much easier to isolate this environment, and it's much more secure comparing to running an application in a uh, server without having any isolation. And if we take a look at what are the core components of a container, so a container will have our application. It will contain all the dependencies that we need to run the application. It can be the dependencies can be the servers or softwares that we need to run the application. In case of a Java application, for example, we need to install JVM or JDK, and it can have multiple library dependencies, config files, and other things. So all those things need to be in the container. And we have a container image, so we define all these dependencies in a file. We write, for example, in Docker we use Docker file to write all the things, and we make an image, and this image actually contains all the things that we need to run the application. And then we use a container runtime to run the image, and this helps us to run many versions or many instances of the container image, so it becomes much easier to scale our application. And in the diagram you can see there's infrastructure where it can contain the hardware. For example, for a PC we need RAM, uh, server racks, CPUs, etc. It goes into the infrastructure stage, and on top of that, we have our operating system, and this operating system runs the container engine. There are a couple of container engines available, like Rocket, Docker, Containerd. In our example, we will use Docker. So the operating system on top of infrastructure runs the container engine, and from the container engine we use container runtime to run our applications. And in a single PC we can run as many container or applications as we want using the container engine. And from the diagram you can see each application or container image can be isolated from one another, so it's a pretty secure. And when needed we can actually also use networking and connect with multiple apps together. So that's not we will not discuss that in details here, but that's also possible when multiple service needs to communicate with each other. And let's talk about Docker and containerization. As I was already telling that Docker is a very popular container runtime. It provides a runtime, it provides a engine, and Docker also have a Docker Hub where we can host our images. Docker Compose is a simple way to write Docker definitions from where we can define our dependencies, we can set up our networks, we can set up our volumes or storage systems. Everything can be done easily by using Docker Compose. It gives us tool to write our definitions in Docker files or Docker Compose files, and then run a couple of commands to build our image, then run those image to run containers and run our applications. So from the diagram, I can describe in a way that, for example, I have developed our Java application, and now I want to containerize it and run it. So what I will need to do is I'll create a Docker file. There I will define the dependencies, like what are the dependencies I need to run the application. For example, I'll need a operating system, and on top of that operating system I'll need to install JDK or Java runtime environment. So on the Docker file I'll say, okay, I want to use this runtime, and then on top of the runtime I'll need to use Maven or Gradle to build our application. So I can also define those steps in the Docker file, or I can build the application locally using Maven or Gradle. Then I can actually create an image using that Docker file. And when I create that image using the Docker file, the image will be created, which will contain all our application source code if needed, or only the binary file that is needed to run the application. And once the image is created, I can push it to Docker Hub, which is a Docker image registry. It's kind of like a storage where I can store my image, and when I need to run it in container, we can pull the image from there. So in the example, we can see that in my container, local Docker is running, Docker runtime is running. I have created the Docker file. Then using that, I have built the images. So my local file, local environment can have multiple images of multiple applications. And once the image is ready, I tag the image by giving it a name or version. Then I can push it to the Docker registry, which is available in the internet. We can store public or private images there based on the uh, subscription we have with Docker Hub. Then when we need to run the application in our, let's say in my computer, so from the container run engine, by running some command, I can pull the Docker image again, or directly run from the local storage where I have stored the Docker image that I created from my application. And using that, when I run the image container, my application runs, and as per my need, I can uh, stop a container, I can start a container, or I can restart the container. So whenever I need to run my application, I can, or if I want to stop my application, I can also do it from all within the Docker ecosystem. And with Docker, there are also a couple of challenges or things that we need to consider or we need to manage. As Docker isolates everything goes into the container and it's isolated. So we need to manage networking and storage by ourselves. So if our application depends on networking, it needs to communicate with the outside world, or even our application needs access to the internet, we'll need to set up the networking part ourselves. We need to tell the container or define the configuration by ourselves to allow communication from the outside world, and also to communicate with the outside world. Even if our application needs storage, it needs to store data in a volume, we need to take care of those things by writing the configuration, so that if needed, our application can mount storage into the Docker container. So we need to take care of these things and make sure when we design our application, we keep in mind this thing. We keep these things in mind, and we also have to make sure we follow the best practices of security considerations. By default, it's isolated, but when we start allowing communications, we need to make sure that we only allow the things that we need, and make sure that the container, it does not contain any vulnerable patches or softwares inside it. If there's anything that needs updates, we have to make sure that the container is scanned properly, and we update the underlying underlying softwares or dependencies regularly. Otherwise, though it's isolated, but there could be bug and security issues within the within the container. And if we want to scale our containers for like for large scale, the management of the containers can become very troublesome work. Let's say I'm containerizing one application and I'm running it, so it's pretty straightforward. But think of a situation where you have like hundreds of applications and hundreds of instances of those containerized application needs running. So we need to always take care of like if any container is running properly or not, if an application is going down or not. If one application or container is down, we have to make sure that another instance of that container or application is running. If there's anything comes up, there's any errors, we also have to monitor all those logs from all those hundreds of containers. So it can be a bit of troublesome work to manage the containers at a scale, but there are tools available which makes these things pretty straightforward and easy. I think we all have heard about the tools named Kubernetes, which makes container orchestration pretty straightforward and easy. There are also uh, hosted solutions available from different cloud providers. For example, in AWS we have ECS, Elastic Container Service. That's what we are going to talk about in this session. So let's get into and know more about uh, AWS ECS. So we know now that using containerization we can uh, make our application ready for deployment in different environments, but it comes with lots of other services. For example, when I was talking about my local environment, I needed to install Docker, I needed to manage Docker services like Docker Compose, Docker Runtime, etc. So what about like if we want to run an application in a server, we'll again need to install the Docker runtime and other Docker related tools in the server. So it becomes a bit like management task on our end. But let's say we are developers, we develop applications, so our main focus should be to keep developing our applications. So AWS ECS helps us to take away that task from developers, and they will manage everything for us. We'll just containerize our applications, we will provide the image to ECS, and ECS will make sure that the containerization services are running in the underlying infrastructure. They will manage the scale, whatever resources we need on demand, they will scale it, they will deploy, run, and manage at scale. And apart from ECS, we know and we use the different AWS services in our applications nowadays. We have S3, we have EC2, we have SQS, SNS, lots of AWS services that we use to develop our application. For example, we can use DynamoDB as a NoSQL database to store the data of our application. So it becomes much easier when we use AWS ECS, because AWS EC has deep integration with all or most of the AWS services. That's pretty easy to use, and it's straightforward. We don't need to configure lots of things, or we don't need to think about the connections, networking, storage, all these hassles. Everything is managed by ECS. So ECS is a fully managed container service provided by AWS, and it can help us to deploy, run, and manage containerized applications at scale. And here's the diagram showing like how elastic container service works. So at first, as we said, like we have to containerize our application and build images. And after building images of our application, we need to store it somewhere so that the ECS service can pull the images from the internet. So we already discussed about Docker Hub, but within AWS, they have their own container registry service, which is named ECR, Amazon Elastic Container Registry. So we can build our images and store those images on ECR. We can then pull that image in our elastic container service. So when we want to use the elastic container service, we define our application, like which image to use to run the application. And to the run the application, we need different resources, right? Like CPU, memory, runtime, etc. So we can define those things in the definition of elastic container service. We'll get to know more about those in the upcoming slides, but we define all the things, like which image to use to run the application, which or how much resources we need to run the application. Then actually ECS will take care of all the things to spin up all the resources and run that containerized application in AWS infrastructure. And when needed, we can run the application in different AWS resources. Like we can run the containerized application in Elastic Compute, Cloud Compute, or EC2 services. We can run the container in serverless mode in AWS Fargate service. So there are different options available how we want to run our application. And on top of that, we get the flexibility to use other AWS services. Like we have the compute options. Like if we want to run our application in serverless mode, we can use AWS Fargate. Then if we want to run it in EC2, we can launch in different AWS regions. It also supports AWS local zones. It can be run in AWS Wavelength. Outpost is you get all the AWS infrastructure in your own data center. So that's also possible. And there's also ECS anywhere. So depending on our need, our application, our requirement, we can launch the application in or the containers on all these supported computing services. And AWS ECS will scale our application and manage the availability. We can define different load balancing, uh, auto scaling features or configurations to make sure that AWS will uh, scale in or scale out our application on whatever definition or rule we provide to them. So it becomes much easier to deploy our application and keep maintaining it, and we can focus on developing our application. And why AWS? What features AWS gives us? So as I already said, if needed, we can use dynamic scaling with AWS. So it also supports container scheduling. Let's say I want to run my application only at a fixed time uh, in a day, and then after the application runs, it can close down, or it can actually just stop, and AWS can make the do that for us. We can schedule our container, and AWS will only run that application at the time we specify, and it can be done for thousands of containers. So it becomes much easier, and AWS will manage the container lifecycle for us. when a container needs to start, when a container needs to stop, if something stops and it needs to be auto started. All these things can be maintained by ECS. And we don't have to think about the underlying infrastructure. For example, if I want to run a Dockerized application in a server, we will need to install the Docker and runtime needs by ourselves. But when we use AWS ECS, based on our need for the runtime, AWS ECS will make sure all the things that is needed to run our application, it's available. So AWS takes care of that for us. And these are the benefits we get when we use AWS ECS. So we get a fully managed control plane or fully managed infrastructure provided by AWS. We don't have to take care of the runtime updates, runtime security, or all the other things. And the underlying hardware, infrastructures, everything is managed by AWS. And it supports, as I said in the earlier slide, that if we want to run our application in serverless compute resources, AWS Fargate provides us that. So ECS has Fargate serverless compute engine integration. It has also integration with valuable and lots of others AWS services and capabilities. And ECS has been used by AWS and Amazon for their own applications at a scale, like very large scale. So it's proven with performance and scaling, and it's really powerful but simple for us as an user. And let's talk about the ECS core concepts. So in ECS we have a cluster. So we first need to create a ECS cluster. So ECS cluster gives us it's reside within a VPC, and VPC resides within region. So if we want to deploy our application, we first have to think like in which region we want to deploy our application, and we need to create a VPC there. I believe these are like some fundamental of cloud computing. So if you don't know about this already, you have to know about learn about these things like VPC, how VPC works, how subnets are created, then how AWS region and edges are binded with subnet and VPC. These are some fundamentals that you need to know first. And then we create our ECS cluster, and ECS cluster can overlap between multiple public or private subnets based on our need. If we want our application to be accessible by outside world, we will need to run it within a public subnet. And for resources that does not need public access, for example like our storage, database, etc., those things can safely be run in a within a private subnet. So we first create our ECS cluster, which gives us area where we can run our containers. And to run those containers, we can use different compute resources that is available for us. We can use EC2 instance to run our application, or we can use Fargate serverless compute resources to run our application. Here in the example, it shows that the containerized application that we want to run, it will run into EC2 instance, and AWS will take care of all these EC2 instances. We will just define that, okay, I need to run this application, and this application will need this amount of resources like two virtual CPU cores, um, uh, 8 gigabyte of memory. AWS will make sure to provide all this from EC2 instances, and make sure when we need this, all these things are up and running. And when we want to increase this, AWS will automatically manage all those things for us. We don't need to think about managing these instances by ourselves. And when we use serverless computes, AWS will automatically scale in or out resources for us. And the important thing that we need to know is the task. So every time we want to run our application, we containerized application, we need to define a task. And to define a task, we use task definitions. And in the task definitions, we will actually define what images we need to use when we want to run the application. And to run the application, if we want to open any port, if we need any networking or storage, all these things goes into task definitions. For example, we have a java application that we have developed, and we want to deploy it in ECS. So at first, within a region, we will create VPC, we will create the subnets, and then we will uh, create a ECS cluster. And within the cluster, we'll need to define task definitions. And before that, we need to build our application and create an image and push that to ECR. So all these things are already, let's say, covered. We have built our application, we have hosted our images in ECR. Now when we define the task definition, we need to define like which image to use to run the application. Then we define what are the resources we need to run the application, and if we want to run it at a specific time or schedule it, that can also be posted there. But let's say we are going to deploy a simple web application, so it will need to be run always. So we'll just run it once. And we can also define things like if any, for some reason, there's error or the container stops, we can also define that okay, it should start automatically. And if needed, based on our need, we can also use load balancer or auto scaling with ECS. And the task are based on our task definitions. When we want to run our application, a task is created and run. And this task is actually will be containing our application, and this task will make sure that our applications are running. And we can also use services for load balancing and couple of other things. For example, here you can see we have defined two tasks here. Two containerized application is running here. So this task is actually responsible for running two containerized application. Here also it is responsible for running two containerized application, and this is the load balance ECS service. So it will make sure that whenever request is coming, the service will actually accumulate the request together and forward those requests to these services. And for any reason, if one goes down, it will make sure that or this containerized the resource is full by taking request of all the request, and it becomes like unavailable or very slow. It can also forward the request to other instances of the task. And it also follows the same thing here, but these two resources are within the private subnet, so only these tasks can communicate with each other based on the definitions we provide in the network settings. But by default, whatever resources we put in a private subnet, it would not be accessible by any other services. And use cases for ECS, so we already know that we can run any kind of applications in ECS. So as a containerized application is easy to scale and manage, so ECS helps us to scale our web application. And if we want to run batch processing applications which needs to work with lots of data or run at a specific time at a given point of time, that can be done with ECS. ECS can be used to run AWS deep learning containers, which is actually pretty resource hungry, and those are used for ML or AI related works. AWS ECS can handle those for us. And even if we want to run our application in multiple cloud environments or hybrid environment, like we want to run couple of our applications in our private data center or couple of our applications in AWS data centers, all those can be done within AWS ECS. AWS ECS supports deployment in hybrid environment. And now we can start taking a look at hands-on example on how we can deploy an application in ECS. So let's
So,
get back
Shubham, like
to code.
we have some
Yes.
questions. So, should
Yeah.
we answer
Okay.
it now? Or, so,
Yeah. Before the hands-on, we can
uh,
take
Parvez
the
Bhai, okay.
example. Yeah.
So, Parvez Bhai asked
Hmm.
how we can manage .env file. We need to
Okay.
want some
So
examples.
Okay. I'm not sure whether I'll be able to show some examples or not, but how we can manage .env file, it's a bit vague question. But what we do is normally in case of like when we, let's say my application depends on a, okay. Okay. So let's say it's a Java or Node.js application, does not matter. And we need to use a couple, it's best practice like to use environment variables to provide dynamically configured values into our application. So locally, when we use, we normally create just a .env file and we put our, let's say, DynamoDB endpoint, that is one configuration value that my application depends on, and we want to provide it dynamically rather than hard coding it into the application, because most of the time we'll need to make sure that our configuration credentials are not actually like made public. So so normally we work locally. We can create a .env file and we provide the values there and we run it. But the best practices is when we containerize our application, we should not provide this file or create a .env file and containerize it within the application, because in that case it can get like exposed. So uh, the best practice is we can push environment variables from our runtime. We I can show the example when we use AWS ECS. It has the options to provide environment variables. So from the definition, we can say that okay, we need this kind of environment variables, and we can provide those. Then we can use also secrets or a storage service like Vault to store the environment variables there and dynamically pull those values on runtime. Then there's also option AWS has couple of services like AWS parameter store, AWS secrets manager, which can help to store all this information uh, into their storage, and when needed on the runtime we can pull these values. Okay, I also want to implement this. Okay. I can show an example. Now, let me get my browser up. So, most of the uh, CI/CD pipelines services has options to provide environment variables. So let's try with GitHub. Let me see if I can show you an example. Okay, let me log in. But for example, here I am showing GitHub Actions. So in GitHub Actions, you will see there is options to configure environment variables. Here, if you go, you can see that GitHub Actions has options like creating secrets and variables. So if you want, you can use your CI/CD pipeline services to store variables like this. And during runtime, when GitHub Actions run a pipeline job, it can read values from these variables. So here is an example of like GitHub Actions, but depending on the CI/CD pipeline you are using, let's say Bitbucket or GitLab CI/CD. Uh, every CI/CD service actually has those options. So depending on your need or which CI/CD pipelines are you using, you need to take a look at the settings, and you will see that there are options to define or provide environment variables from uh, your CI/CD environment.
So like, can you little bit zoom the your project? So I think
Okay, okay. Yeah, I'll do, but yeah, let's just start seeing an example. So before I start here, let's say like I have created a sample Java application. It's not 100% like fully featured, but it runs and shows us some response. So here I'm giving you an example of, mm, let's say, okay, this is the code. Like it's a simple Java application which will run in a Java 17 or JDK 17 environment. So what I do is I have already created a. If you are a Java developer, you will know that in Java we build our application and we create a .jar file. So what the this Docker file does is it takes the .jar, or you can say it's a binary of our application source code. So it takes it and then it's actually runs the JDK 17 environment and copies this jar file there, and it just runs the application and exposes the port 8080, because the application that I have developed, it's using Spring Boot framework, and the application will run on port 8080. So yeah, I have already developed the application and pushed it to ECR. So if I go to AWS service elastic container ECR, oh okay, it's asking me to log in again. So one moment. And I will zoom in. Okay, it's, let's wait. Okay, so I'm logged into my AWS account, and now I will show you the ECR service elastic container registry, where I have already created a repository. So you can think of repository like GitHub repository. So in GitHub repository, we store our source code. Here in ECR repository, we will actually store our image, container image, the application that we have developed. We have built images of that source code or application, and we have uh, built the image and we have pushed the image here. So this actually contains the image of our application, and I have tagged the image as latest. So the tag is important because we can have several versions of our application, like, and we call like I developed my application today, and I have created an image and I have pushed it. After 7 days, I have made some changes to my application. I have created another image from that version and I have pushed that. So I have to maintain a version number for my image or application, so that we know that on which version of my application I need to deploy. So here, for simplicity, we have made the tag latest for our image. So this image actually contains the Java runtime and this jar file, and when we run this run a container from this image, it will run the Java application and it will expose or open the port 8080, so that from the outside world we can access or connect with the containers port 8080. So let's get back to ECS. And now we have already taken a look that all the what are the components of ECS. We have already taken a look that the components has where here, like clusters. We already know container and images. Now we will get the chance to take a look at clusters, task definitions, or services in a hands-on example. So first we need to create a cluster. Let's give it a name. So let's that's the name of our application. So let's name it Ola cluster. And we need to define what infrastructure we need to or we want to use for this cluster. It can be both AWS Fargate or EC2 instance, or it can be only EC2 Fargate serverless. So it will depend on our need, like what kind of infrastructure we want to use. Fargate means it will provide serverless infrastructure, so it's in pay as you go model. So if you want to run your application for some time and then it goes away, or you are not sure about how much resources you will need your application at the moment, you can just start with this. It will not it's pretty on demand. But if you know that your application needs this much amount of resources for this much amount of time, you know that your resource demand is consistent, then you can use EC2 instances. Those who already know about EC2 instances, you know that to run EC2 instances, we need to provide instance types, which has actually the configuration for how much CPU you need, how much memory you need, and lots of a couple of other options actually. And you can also define the provisioning module, whether you want on demand EC2 instances or spot EC2 instances. You can also provide auto scaling group to make sure that based on need, these containers or EC2 instances can actually auto scale. For simplicity, we'll use AWS Fargate for now because it needs less option and it's pay as you go. We can just run this for example here and then destroy all the resources pretty easily. And all other things are optional, so we'll keep these options as it is. So let's create the cluster. So a cluster is like creating a isolated land where you can define different tasks and run it. So okay, it says create cluster is error. So okay, I'm not sure why it happened, but this is the first time I got error by while trying to create a cluster. So let's try again and see. Okay, I think there's something weird going on with AWS.
Can you change the region?
Yeah, we can try. But most probably there's something wrong going on with this region. And as we will be using Fargate, one thing, ECS is free. When you are using ECS service, it does not charge you anything, but you will have to pay for all the resources that you will use within ECS. And though we can say that ECS is free, but whenever you run ECS, there will always be some cost, because when you will run your application in ECS, you will obviously use some resources, like whether it's AWS Fargate or it's EC2 instances. So you will be charged for the AWS Fargate resources you use. You will be charged for the AWS EC2 instances that you will use. Let's try again and see. If not, I will try to switch back to another environment and see. Okay, this one is being created. So CloudFormation is a AWS tool. So for some reason it failed. Let's see why it failed. Okay, AWS itself uses CloudFormation tool to create the clusters, but for some reason this failed. I'm not sure why, but I'll keep it as it is, and as this one is being created, so it will take some time to create it. So yeah, it's already created, as you can see. uh, Down the line in the background, it creates a couple of things. So yeah, the it's created, and you can see the status active. So it's fine, our cluster is created. So next, what we need to do is we need to define a task definition, and we have already mentioned you that the task definition will actually contain all the information that is needed to run our application. So let's go to a task definition. So from this panel, we can come back to task, and but you will find the task definitions options here, and we will define a task definition here. And the task definition can be created in two way. One is to use their visual editor, or if you are familiar with the JSON format of the task definition, in some cases people provides example of task definitions with JSON format, so you can just copy paste in that case. But for simplicity, we'll use create new task definition for now. And you may keep in mind that these task definitions are versioned, so that you can easily manage the deployment of your application in different versions. So let's give it a name. Let's say Tumula uh, task definition. And as we said, we will use AWS Fargate. It will be Linux. Network mode is the default one. Uh, and here we need to define the CPU and memory. So it will depend on your application, like on which language your application is dependent on, developed on, what is the minimum requirement of CPU or memory to run your application. Based on those need or requirements, you will need to set the CPU and memory here. So for me, let's say, I think I'll try to keep it minimal. It's a small minimal Java application, so it should not take much. And yeah, I'll take one virtual CPU and 2 GB. And we'll need a couple of these roles, but we'll come back to here later, because we have seen that in ECS If we want to connect with other AWS services, then we will need to use a IAM role that will help to provide access to other AWS services from our containerized image. For now, we have not created any task role, so we'll uh, keep it none. But it will we will need it. We'll see, because our application depends on DynamoDB. So when it will run, if it cannot connect to it will not find a IAM role, or it will not find the permission to connect with DynamoDB. So I believe it will fail, but I will keep it as it is now, and we'll need to create a new role so that our task can be run by AWS, and it will be automatically created. So we'll have this option. And now we will need to define like which uh, image we will need to use to run the container. So as I have already said that I have already uh, created the image and pushed it to ECR, so we can just provide this information here. So we can copy the URI from here, and we need to also mention the tag, and we need to give it a name. So let's say we give it a name. This will uh, is task must have one essential container, so at least one container. A task should have at least one container, so we can have multiple containers, and then we need to define one as essential container. For example, here we only have one application and it will run one container, so we don't have to think about any other things here. And we need to open the container port 8080. Let's say it's application port, or we don't even have to provide a name, but it's fine. And if needed, we can also provide conditional limits. So there are a couple of more options available, which is not actually needed for us. And here comes as I said, like during runtime, we will be able to provide environment variables for our application. So as you can see in the task definition, we can provide environment variable and value. So this answers the question from couple of minutes earlier, that you wanted to know how you can use environment variables if you want to deploy a Node.js application. So if you are deploying a Node.js application in ECS Fargate, you can easily define your environment variables and values here in the task definition, and when that application will be run as a task, it will actually be loaded with all these environment variables. So in my case, I don't need any, so I'll keep it as optional. We can also use log collection, so that like when our application runs, obviously our application will log some information. So AWS can use ECS can use AWS CloudWatch to provide all the logs to CloudWatch. So by default, when I can use log collection or not. But make sure that you know that AWS CloudWatch is a paid service. So whatever amount of logs will be stored there, you will be charged. But for example, in this example, we'll see this log collection, and when you click this, it actually fills up the most of the values automatically, so we don't have to provide anything. Then there are a couple of other options available here, which are optional, some of which are will be needed if you want to use load balancer or a couple of other things. There are a couple of other Docker configuration. If you want to do any advanced configuration, there are container timeouts, network settings, lots of things are available here. So, and we don't need any storage. If you want any monitoring, like metric collection, like when your application runs, it will consume resources like CPU, memory, etc. If you want to collect information like how much memory or CPU is using by your application, if you want to trace information like how your application is running, if there's any error, all those can be also collected. But I will keep all the optional settings unfilled or ignored for now. And let's come back to the task definition again. So uh, I think all the things are filled up here now. I can go and just create the task definition. But before I do that, let me share one more information. Like your application can be developed in a way that it depends on multiple container. For example, let's say I have developed a PHP application and I have containerized it. So by default, a PHP application needs a web server. I know that PHP has its built-in web server, but it's not production ready. So in most of the cases, what we do is when we develop a PHP application, we use a web server like Nginx or Apache. So in that case, to run your application in PHP, you may need two containers. One container which will have your PHP application and all the dependencies, and secondly, you may need a Nginx container so that your traffic first goes to the server container, and server container actually in the underlying infrastructure, it actually serves from the PHP container. In that case, you may need to like use multiple container. So depending on your need, you can define as many container needed for your application. Here you see the option to add multiple containers. But okay, yeah, it's all fine now. Let's create the definition. So if all the things are successfully provided, we have the definition ready, and you can see the information here, like what are the CPU task will use, what are the memories it will use, then which container it will run, and you can see all the definition in JSON format here. So from now on, if you want to like make changes, you can make changes from the by creating a new revision of this task definition, and the version will be updated. You can now copy this JSON and use it to create a new task definition for another application. So there are a couple of more options, like if your task needs to use a storage, you can find those storage volumes information here, but in our case we don't need anything. And there are a couple of other options which we don't need to think about at the moment. And from here we can deploy a task, and a task definition can be run as a task or also as a service. Let's go to service and uh, talk about that a little bit. So when you we have created the cluster, like our land, which will have all the resources. We have created the task definition that will help us to run our application, and we can also use service to run our application at a to keep running a task. We can define a service which will help us to keep our task running for a long time. So the difference is when we run a task, it will run, and if it finishes, the task will end. But it's suitable for batch application, let's say, or I want to just try it for example. So it will run, as you can see from the description, that uh, it will run, it will do something, and it will terminate. For example, a batch job, it runs, it processes something, it closes. But as you can see, we are running a web application, so in our case we don't want the task to be terminated automatically. So we will create a service which will actually trigger a task, and it will make sure that the task keep running, so that whenever I visit my web application, it's available there. So I will define the task definition here. I need to give a service name, and I uh, tell service can be used with load balancer. Let's say I want to make sure that uh, three instances of this application should always keep running. Then load balancer can forward traffic to these three running tasks or containers. So in that case, I can also tell the service that how many minimum number of tasks the service should keeps running. So that gives us like much more flexibility if we want to scale our application. But in this case, we'll keep it as one. There are a couple of other options for like if when we will be deploying or making change in our application, and we want to deploy a new version, we can tell ECS that, let's say, 5 tasks were running. So whether it should start upgrading those tasks one by one or all at once. So there are a couple of deployment options available, and yeah, there are a couple of options available, so which we don't need to take care of. But you can already see that their service discovery option, if we want to discover this task from AWS, from like a DNS, if we want to uh, and we will obviously need to create the networking resources, because we have already shown you in the diagram that is ECS will use EC2 or serverless resources, like Fargate resources, and it all needs to reside within VPC and within subnets. So we need to define those things here. So by default, our AWS region had one VPC and some default subnets created. So all those are here available, and all are so I'll keep all the default settings selected for now. And as it will be a web application and we need to like access it from the internet, so we will make sure that our task gets a public IP so that we can access it. And as you can see, there are a couple of other options available. As I said, like load balancing can be implemented, service auto scaling can be implemented. So I'll keep all these things as it is, and let's create the service. So it will take some time to make the deployment. So the service will start running, and it will start to run the task for us, and we will be able to see the task running there. So let's see. So if it's not running, let's deploy. So we have said that the task we need one desired one, so it's 0 running. Let's wait for some time and see, because as you can see, the service is being deployment and it can take some time to deploy it. So let's wait and see. and it will take some time, and when our application runs, I believe it will fail somewhere because we have not maybe set up the firewall or a couple of other AWS policies to access DynamoDB, but let's wait and see. And it will be useful for us to understand what's going on within the container, as we will be collecting the information or the logs on the CloudWatch. So whatever happens with our application, we will be able to see what's going on into our application from these logs. So if I come back to logs, we should be able to see, yeah, we can see a log group for our task definition, but I think it should be, oh, okay, it has already, yeah, started to run. But yeah, our application has already started running, but it's throwing an error. So it might be possible that the way our application is running, Java is not being able to run the application properly. That's why it's throwing this error. So let's come back to our application definition and see, or maybe it's still not ready yet. Hmm. Okay. Okay, we can see that the application is being run, but the container is stopped. We also can see that the container was terminated with this error. That's why it's not running. And our service, as we have mentioned, that it should always keep one task running. It keeps retrying to run the container again and again. So unless we fix the problem with our container, it will keep that running. So let's see and try if we can uh, solve this issue. So we can see that the container was running. In the log, we'll be able to see the error. So it says when the container ran, it uh, terminated with this error. Though I'm not sure why this is happening, because when I was running the application locally, it was running fine. So let's Google it and try to see if we can find anything. Mm, okay, I think I got what is wrong. Because I'm running in a Mac application, like I'm running it in my Mac OS. So when I build that image, it was built for ARM architecture. That's why, but I am running the application in Linux, so it got mismatched and this error happened. So what I need to do is I will need to build my application again and make sure that it's I provide this, that it should be built for Linux, and I have to push my application again. So let's try this command, docker build. So this was the command that I used to build my application. So uh, it's not okay. So let's try to provide the platform specific flag to make sure that it's run, or it actually builds for the platform. Let's see. So it's building again. In the meantime, let's see our task. What we will do is we'll stop the task service for now, because delete the service for now. Otherwise, it will keep running and failing again and again. So it's deleted, and let's fix it. So it's taking some time to build it again. So let's get it completed. Yeah, it's completed. So let's tag it with the tag latest, and let's push it again. And if we come back to ECR, we can see the last version was created at 443. So once the push completes, we'll get the new version and we will be able to see the updated one. Let's see here. This is the image, and it was pushed a couple of times earlier. So let's wait and see.
Shuman bhai, has some answer to your question
If
from.
we want to use other vendors, load balancer is possible in the AWS. I
Yeah,
don't think so. You cannot maybe
we can use
directly. Yeah,
we can use third party load balancer in
yeah,
AWS.
yeah. AWS, I
We get
think,
from the
provide
marketplace.
options. Mhm.
Yeah, the options from marketplace. There are several options.
Okay. Yeah, like by native integration, you cannot, but there could be, like you said, third
Yeah, yeah.
party
Yes.
integrations available. We can write our application in Windows, Mac, or Linux, but how can we resolve it for others? I'm not sure whether I have understood your question or not, but one of the main benefit of using containerization is you use containerization to develop your application, and the container has all the things needed within the container. So it doesn't matter whether you write your application in any environment, but when you provide the container, it should run in any application, like any operating system or environment. Yeah, we have created the application, and we can run it locally to make sure that it's running. As you can see, I will run the application locally first now to show you guys that okay, it works. So you can see that the application is started running. And if I come back to Postman, where I can request to this port where the application will be running by default, As you can see, I get this response. And if I try to shorten the URL, it may or may not work. I'm not sure whether from local run it was able to connect with the DynamoDB or not, but let's try. Okay, it throws internal server error. Though like there could be something happening that's not correct, but you can already see that my application is running and it can actually throw responses. So what are the why it failed? I think it failed because it cannot connect to AWS. Yeah, as you can see the error, it says that unable to load credentials from any of the providers in the chain because I am running it from locally. It cannot connect to AWS, but that confirms that our application is running fine. So let's push our application image to Docker again. So that's the push command, and I'm passing the platform flag now, but it says, okay, Docker push does not have this flag. Then how come they provided me this? Let's see. Hmm. Okay, do I have built it? So let's try and see. If it doesn't work, I have to try again. Let's push it. Okay, it's already pushed, so that's fine. So let's come back to our ECR registry and see. Yeah, we can see that the latest one is here and it's tagged as latest. So let's try to run the service again or create the service again to see, or simply I will create the service later. First, let's create a task manually and see whether it can run or not. Then we can create the service. So let's try to run the task. Launch type would be forget latest. I will only run the task, so it will take the latest revision. Fine. Networking, I will keep it as it is, and yeah, let's try to run it and see how that goes. And we'll be able to see the log here, but it's okay, it will take some time to create the log, so let's wait. And it's provisioning, it means like it's now creating the resources, like the compute resources, memory, virtual CPUs, etc. And it may take some time to create all this. And now you can see it's running. So it seems our error might be gone. Ah, cool. We can see that our applications is running now. So that solved our problem. So that's good thing. So now we can stop the task or see. So let's go back to, so that come back to our clusters view, and you can see that our cluster has one running task, and it keeps running because by default when we run the application, the process that runs the application, it does not stop, so we can still keep running it without the service. So let's go back there, let's go to the task and see how we can access it. So in the networking, we can see that it has been assigned a public IP address, that because we wanted to uh, have it. And if we go back to CloudWatch log, we'll be able to see all the information from the application or the logs that the CloudWatch application is providing to. So yeah, you can see the application is running. So Leo, what I will try to do is Let's try to access the application and see how that goes. So, okay, it does not do anything. Let's try to access it from the browser, though I'm not sure whether I'll be able to or not, because most of the cases browsers try to connect to HTTPS. But let's see. Okay, browser cannot access it because I think okay, there could be a couple of reasons why it cannot connect. I will tell you later, but let's try from Postman. And if it cannot connect, I may know why. Okay, let's update the link. Yeah, let's try. It's not going to connect because I think the problem is the task that is running, and we have deployed in a VPC, we have deployed in a subnet. So we have to make sure that the application is running in a public subnet, so that the application can be accessed, and we need to make sure that we have security group rule uh, in place so that the application can be accessed from anywhere on port 8080. By default, all these things are not there, so I believe that's why the task is running, but we cannot access it from the internet. So let's fix those things. So let's come back to networking and go to this subnet and see what access does this have. Does it have access to the internet or not? So you can easily see in the route table. Yeah, okay. By default, the subnets that AWS provides, these are public subnet. And how I can know? As I can see in the route table that for all the traffic, it says that it should go through the internet gateway. So the subnets are fine. We have deployed our application in a public subnet. Let's go back to subnet security groups. I think security group is the problem, most probably. No, it says inbound rules. So all traffic for all protocol or port range can be accessed. Okay, that seems fine. So the default VPC also give access to uh, all the ports. So that should also be fine. Uh, so it means subnet is public, it's fine. Security gear group should also give access, so it should also be fine. But why we cannot access it? Port 8080. Let's see if we can find anything from here. Otherwise, it could be possible that in the configuration we have not properly mapped our container to run on the port 808 or expose port 8080. Let's see if we can find it. So in the task definition, we can see, okay, we can see that host port 8080 and container port 8080 should be available. So protocol TCP, app protocol HTTP. Yeah, it seems fine, but let's see if we can use AWS tool to find any more information. So destination. Otherwise, okay, it seems fine. Our application has been deployed and it's as you can see from the cluster, one task is running, our application is running fine. In the metrics we can see like there's some metrics at the moment, but we can also see how much CPU or memory is utilized. We don't have any scheduled task, and this task is running. So I'll try to see if we can solve it. Okay, the path it also says it's reachable. Let's try again. Source, our source would be instance, no, uh, from this. Okay, I think this is fine, but let's try to request it again and see. Okay, it seems it's not working. So what we can try is, let's try the service first. Like last time, for the last time, we will try the service and see if we can access it or not. But I think you get the idea how ECS works and how you can run your application in ECS. So I'll stop the task. Okay, it's gone. Now I'll try to use services and use its load balancing feature to see if we can reach the API or not. So let's go to launch type, forget latest service, service name, desired task. We know this. Okay, it will take lots of time, no problem. Yeah, let's come back to this and see. So subnets are selected, default selected, public IP is there. Let's use the application load balancer and see if we can now access it if we use a load balancer or not. I'll check 0. So we will load balancer will listen on port 80, and once it gets the response on port 80, it will health check and it will forward the request incoming traffic to the container running here. And if I go back to CloudWatch log, let's see when we stop the task what happened. We need to see. Let's see text format, where display text. Yeah. We need to make sure in which port the application was running. Started application, active profile, starting service, starting root, started application in seconds. Yeah, it was running on port 8080, so that's fine. Okay, let's run it and see for the last time if we can make it work and access it. Joy, can you guess what could be wrong? I cannot think of anything at the moment why we were not being able to access it.
Let's see now what will happen.
So it's like common when working with cloud. You will see that many times you have created the resources. Most of the sometimes you may not be able to access it because there may be some networking firewall rules or security group rules that is not there that needs to be. So it's pretty common problem. Yeah, let's wait and see. Yeah, is there any other question?
Kind of right.
No. Okay, fine. Yeah, we try to see if using load balancer works, or otherwise, yeah,
Let's
we
see.
will finish the session here. Yeah, it's taking some time to create all the resources because it's now creating the load balancer and a couple of other things. So in case you don't know about load balancer and other things, you can go to EC2 and you will find the options of load balancers there. So you will see that it's being created here now. So the load balancer is being created and the load balancer will now provide a DNS name here. Yeah, this one I think. When we try to access this one, we'll
Yeah,
see if it
we can
works
use
or not.
the DNS name. Yeah.
Yeah, we'll try to use this one if it works or not. It's still provisioning, so let's wait and see. And the load balancer will now forward the traffic to the target group, and the target group is the uh, this task that will run. So all of these are still in progress. So it's not fully finished. So let's wait and see because it is still in pending state and in progress. So let's wait, but we will try to use this DNS for now. So let's put it there. See if it's still available or not. No, okay, it's yet not available because the task is not. Oh, okay, the task is running now, and we should be able to see one healthy instances here when it's ready. Yeah, we can see it has one.
It should work, I think.
Yeah, it should work. Otherwise, yeah, I'll have to debug later to see what went wrong. But yeah, let's see. No, okay, it's let's see the details here. So we go to the service. Task one desired task is running. It's completed. Load balancer health. It can find healthy, so it means load balancer can actually connect to the container. Otherwise, it would not find it healthy. And if I see the load balancer, you can see that it will listen to port 80 and it will forward the traffic to the task. So it should work fine now. Let's try to reach it. Mm, okay, it's still having timed out, so there must be something wrong. Okay, let's see. This is the one latest one. So yeah, it says the application is running. Okay, yeah, it seems fine. The application is running, but we still cannot access it. Okay, there might be something wrong then. I'm not sure. Uh, Even the load balancer cannot be connected. Why? Mm, Internet facing request. Okay, yeah, I'll just try to access it again. If not, I will have to debug it further to understand what's going on. But I think you can understand the idea how ECS works and how you can run your application in ECS. So VPC is fine. This is fine. Let me check the subnets. So if we come back to our VPC and check the route table, yeah, it says it's connected. Mm, let's go to VPC and VPC. Yeah, we can see that all the three subnets that we have is connected to the internet. So all these resources would have been uh, available. Oh, 32. Task is running fine. What is the IP of the task? Yeah, that's fine. Let's see. Okay. I think there might be some firewall or security setting that is maybe not making it accessible. But yeah, I think this is all from our today's session. This is how we can actually, yeah, create a application and host in ECS. So to sum up the workshop, we have known about how containerization work, how it can help us to containerize our application, how it's useful to deploy applications in different environments. Yeah, that's all. And I try to answer the questions of the audiences. And to like conclude the session, I am Mohammad Shonmullah Selim. I'm working as a senior software engineer at a company named Mimecast. We are a cybersecurity and email security company. I live in the Netherlands, and yeah, besides that, I also volunteer as a AWS community builder. So this is my second year, and you can find me in most of the social media with this handle Shumon M Selim. Yeah, Joy, over to you. Thanks for giving me the chance to share the session today.
Okay, thank you, Shuman Bhai, for your lovely presentation. So I think we have no questions left, but thank you, Jangir Bhai, for inviting us. Definitely, we'll go some time in your office, and I think we can quit for now. But yeah, to this session because we have no question left. Thanks again for watching this.
Mhm. Thanks, everyone.
Okay, thank you. Okay, bye bye.
Yeah, bye.
Okay.